Okay, we've been discussing Chapter 7, which we've been learning about rational expressions, how to simplify them, multiply, divide them. But in this section, 7.6, we are going to be talking about how to solve equations that have rational expressions in them. And basically what that means is it's equations with fractions. And we've already done this with simple equations. For example, we've solved something like this first example where we have 1/2 x plus 3/5 equals 1/5. Remember how we did that? What the key to that was? Well, if you don't remember, what we did was we multiplied by the least common denominator. And what is the least common denominator in this case? Remember, it's the smallest number that both 2 and 5, those are the denominators, that both 2 and 5 go into. What would that be? It would be 10. And so what we do is we take the 1/2 x and the 3/5 and the 1/5, and we multiply all three terms by 10. And sometimes students like to write that as 10 over 1. You can do that. 10 over 1 times the second term, and 10 over 1 times the 1/5. And the advantage of that is, well, the 2 goes into the 10 5 times, there goes that denominator. The 5 goes into the 10 2 times, there goes that denominator. And also this 5 goes into 10 twice, there goes that denominator. All our denominators are gone. And so what we're left with in the first term is 5 times 1 times x. That's equivalent to 5x. That term's nice. The next term is plus 2 times 3, which is 6. And then that equals 2 times 1, which is 2. And we get an equation that is much, much nicer to work with. We know we would then subtract the 4 to the other, or subtract the 6 to the other side, and that would give us 5x on the left equals -4. And then we divide by 5 both sides, and we get x is equal to -4/5. This is something we've done before, and we're not really doing anything new in this chapter. All we're doing is we're continuing to do that same idea, and we are going to do it with just some more complicated equations. So if we take a look at example A here, we want to multiply by the least common denominator. And what is that in this case? What's the least common denominator here? Well, I usually like to start with the most complicated denominator. The most complicated one is x squared. So if we have that, we know we need at least x squared for the least common denominator, because that will get rid of this denominator. Will x squared get rid of the x in the middle one? It will. And there is no denominator in the first term. So that should be good. Now, the most common mistake that I see when students are doing a problem like this first example A is that they forget to multiply the term that doesn't have a fraction in it by x squared. Remember, if you multiply something in an equation, you have to multiply the whole equation, otherwise the equation doesn't stay balanced. So we're going to multiply that by x squared, that by x squared, and then the one that's commonly missed is we're going to multiply the 1 by x squared as well. When we do that, well, there's one x here that will cancel with one of the x's in that term, and then both x's cancel on the far right side. And so what we're left with is x squared times 1, that's x squared, then minus 3 times, there's still one x there, so minus 3x, and that's equal to just -2. Okay, now that we've gotten rid of the fractions, we still have some more work to do. What type of equation is this? How do we solve this? This is a quadratic equation. It's a quadratic equation. How do we solve quadratic equations? The way we solve it is we set the whole equation equal to 0. That's what we do first. And then we factor. So we're going to do that. We need to get it equal to 0 first, which means we need to add that 2 over the other side, because it's a minus 2. And so then our equation becomes x squared minus 3x plus 2 equals 0. And I think that's factorable. This isn't too bad to factor. It becomes x minus 2 and x minus 1 equals 0. You remember what we do from here? We set the x minus 2 equal to 0. We set the x minus 1 equals 0. This means that x equals positive 2. This means that x equals positive 1. And now we need to check one thing. We need to check to make sure these answers are okay. There's nothing wrong. There's no bad answers. So I skipped over this at first because I wanted to jump right into solving, but let's go back up to this paragraph that's in your notes. It says, for any equation that has fractions, we can always eliminate the fractions by first multiplying both sides of the equation by the LCD. We did that. We did that at the very beginning. But before solving a rational equation, you should always write down the values for which the equation is undefined. Remember how to do this? Remember we did this in 7.1. We said there's going to be some values that we can't have because when it's undefined, remember that means that happens when we divide by 0. And so for this particular one, we know in this denominator right here, we know that x can't equal 0, and then we also know that x squared can't equal 0. Well, either one of those tell us this. They both tell us that x can't equal 0, because if x can't equal 0, then x squared, 0 times 0 is also equal to 0. So then we say, okay, x can't equal 0. If x is 0, then we get 0 in both denominators. And we go back and we look at our answers. Okay, well that's not a 0, the 2 is not a 0, and then the 1 is not a 0 either. So both answers are actually okay. I'm going to write this in set notation. X is equal to 1 and 2. Okay, there's our answer for A. Now we'll look at one that's a little bit more complicated, and I'm going to start right off here at the beginning with figuring out what x cannot be equal to. So we just have, this denominator, the 2, that will never be 0, but the other one, the x minus 5, that could possibly be 0. So I'm going to say, okay, well that can't be 0, and we know then if we add 5 to the other side, this says that x can't equal 5. So we'll just remember that. We'll remember that after we're done solving here. Okay, what's our least common denominator here? What's our least common denominator? Well, we know we need an x minus 5 to cancel this denominator and this denominator, but x minus 5 won't cancel the 2, so we also need 2. So we can write it like this, 2 times x minus 5. And so if we're going to cancel, we multiply by the first term by 2 times x minus 5. We multiply the second term by 2 times x minus 5. And then we multiply the last term by 2 times x minus 5. And this will allow us to eliminate all three denominators. Because in the first term, the x minus 5's cancel. In the second term, the 2's cancel. And then what cancels in the last term? The x minus 5's. Those cancel. And so what we're left with, first term, x minus 5's are gone, so we're left with x times 2, or 2x, plus, it's a plus in between. 2's cancel, so we're left with 5 times x minus 5. And then that is equal to 5 times 2 is 10. Okay, how are we going to finish off solving this equation? Hopefully you're thinking to yourself that we got to distribute here. We can't have those parentheses if we're going to solve. Okay, so this is 2x plus 5 times x is 5x plus 5 times negative 5, that's negative 25. That's equal to 10. Then what? Then we combine like terms. 2 and 5x make 7x minus 25 equals 10. Then we go ahead and add that 25 to the other side. And that gives us 7x. 10 plus 25 is 35. Divide both sides by 7. And we get x is equal to 5. Now, we got x equals 5, but we said that x couldn't be equal to 5. So we actually end up having to throw that answer out. That solution is no good. So the one answer that we got is an answer that won't work, which means this has no solution. And kind of the shorthand for writing no solution is that we write it like this. We write no solution. Okay, we have one more example. Example C. Now this one looks a lot more complicated because these denominators look ugly. But what we can do to simplify this is we can factor both sides. We can factor this denominator. Okay, this denominator will factor to x minus 9 times x plus 1. And then this right-hand denominator, that will factor to x minus 9 and x minus 4. Negative 4 times negative 9 is positive 36, and negative 9 plus negative 4 is negative 13. Now looking at that, look at those denominators. Do they have anything in common? Well, they both have x minus 9s, but this one has an x plus 1 and this one has an x minus 4. So our least common denominator for this example is actually going to be x minus 9, x minus 4, because that will cancel the right denominator. And if I multiply this side of the equation by that, I got to multiply this side of the equation by that. I got to multiply by x minus 9, x minus 4. Now, x minus 9 and x minus 4 is not enough to eliminate the denominator on the left side, because I still have this factor of x plus 1, so I also need to multiply this side by x plus 1, which means I also need to multiply the other side by x plus 1. So that is a pretty nasty looking least common denominator. However, a lot of stuff is going to simplify here, because on the left side, x minus 9s and the x plus 1s cancel. And then on the right side, the x minus 9s cancel and the x minus 4s cancel. And so what we're left with is, on the left hand side we have this x plus 3 that was already there, but then we also have this extra factor of x minus 4 which did not cancel. We multiply by the least common denominator. And then on the right hand side we have this 6 which was originally there, and then the extra factor of x plus 1 right here. So again, just like the previous example, we want to get rid of our parentheses, so we're going to distribute here, or FOIL, whatever you want to call it. That's going to be x times x is x squared, x times negative 4 is negative 4x, we have 3 times x is plus 3x, we have 3 times negative 4 is negative 12. That is equal to, distribute again, 6 times x is 6x, plus 6 times 1, that's 6. And look again here, what kind of equation we have. Notice there's this x squared, just like example A had the x squared. That means we have a quadratic equation, which means we need to go back through and go through the same process. We need to get everything set equal to 0, and we need to factor. So first of all, combining like terms, I have x squared, negative 4 plus 3, that's negative 1x, or negative x minus 12, equals 6x plus 6. Is that set equal to 0? No, it's not. So this 6x needs to move over here, becomes a minus 6x, and this positive 6 needs to move over here, becomes a negative 6. Now, Simplifying, I have x squared. Negative 1 plus negative 6 is negative 7x. Negative 12 plus negative 6 is negative 18. That's set equal to 0 now because we moved everything on the right hand side. Now what do? We set equal to 0 and we factor just like we've been doing. So if we go ahead and factor this, what do we have? We have x minus 9 and x plus 2. And then we set each of those equal to 0. X minus 9 equals 0, which means x equals 9. And then x plus 2 equals 0, which means x equals negative 2. And if you look back at the original problem, we look back at our denominators, we have some values that x can't be equal to here. X can't be equal to what? What was it? It was x can't be equal to 9, negative 1, and 4. So this answer right here, we can't have it. X equals 9, we can't have. We have to stick with just x equals negative 2. That's our one answer. So that does it with this video. Thank you for your time. We'll see you in class.